Hello everyone, and today we are going to discuss a very interesting topic. But before we start, you already know it's the summertime and we all feel the heat. But what if anyone comes and offers you this? Yes, it's a lemonade, right? And it really gives you a lot of relief, especially in this sweltering heat. Now, you all know that it's a source of vitamin C. But my question is that why does it taste sour? Is there any reason behind the taste being sour? Yes, there is a reason. They taste sour because there is the presence of acid. Okay, they have acid, and all the acid they taste sour, right? So that is the reason. Okay, so you all have had experience of this lemon, right? Lemonade, it's really very sour in taste. Okay, so please remember that this is sour because it contains the citric acid, right? So now in this pandemic era, you all know that immunity is very important for us, or for our body, to help us fight the viruses, right? So even in the COVID care centers, they are giving them regular supply of vitamin C, right? So see, there are many advantages, and you can very well identify that these two advantages were mainly helpful in treating coronavirus, right? So there are many health benefits of vitamin C. Okay, so basically vitamin C and this citrus food, they contain citric acid, and that's the topic of today. We are going to discuss acid, bases and salts. So the best thing would be, let's discuss some more applications so that we get to know most of the applications in our daily life. Okay, so the first thing can be, you already know that acid, this acid, one acid is present in our stomach, and that is HCl, right? Hydrochloric acid. Basically it has two purposes to serve. That is, first is killing the bacteria and viruses which enter our food, and second thing, it helps in the digestion, right? It has got very powerful digestive enzymes, and it helps in the digestion of the food, breaking the food biomolecules like carbohydrate, vitamins, proteins into simpler compounds, right? Now you see this person, he is suffering from acidity, right? So let's take an example. Let's take this baby. I found him suffering from acidity, and please remember that whenever acid is troubling you, okay, you can nullify its effect by a base, okay, and vice versa is also applicable. So now we see the baby suffering from acidity, and you all know the solution, this eno. Whenever we are suffering from acidity, we go for eno and the baby feels happy. So what is our conclusion? The main conclusion behind this is that eno is a base. Okay, as I said earlier, if you want to neutralize the effect of acid, go for the base, and if you want to neutralize the effect of a base, go for the acid, right? So this thing, this neutralization principle works, and it has tremendous application in our daily life itself, right? Then you see vinegar here, right? It has also many applications. It's actually the acetic acid. You see all the Chinese food, it's a common ingredient there. Apart from salt, they use vinegar, right, which is an acetic acid. Basically 5 to 8% of acetic acid in a solution makes the vinegar, right? Apart from this, it is also used in pickles as a preservative, because it helps in the inactivating the growth of bacteria, okay, which increases the shell life of the food. Now let's be clear with respect to the differences, okay, and the best way to remember the differences between an acid and a base is the 4B formula. Okay, 4B formula: B for base, B for bitter, B for blue, and B for bathing soap. You can also say baking soda, right? So these 4 points are important. Now what does it mean? Base is bitter in taste. If you take the litmus test, if you go for the litmus test, it will give you blue color, and all the soaps which are soapy to touch, right, they are nothing but the bases. And base release hydroxide ion. Okay, as you can see, I have taken a base here. This is sodium hydroxide, so it is giving me hydroxide ion, right? Similarly, acid, they are sour in taste, they give red color in litmus test, and they the example is acetic acid, lactic acid. There are so many examples which we will learn just now, okay, and all the acid, they release H plus ions, right? You see the example of HCl here. So it has given you H plus and Cl minus ion, right? So there's this litmus test. Okay, so litmus test, you already know litmus can be in the form of a filter paper, like here this one is the filter paper. We can also have it in the form of solution, right? So please remember, in red color we get in the acid and blue color we get in the base. Okay, and there are some facts, interesting facts, like this acid word, it is the Latin word which has come from acres, and it basically means sour, and you all know that acid is sour in taste. Okay, similarly bases are slippery and they are soapy to touch, is already known to you, right? So now let's see some of the naturally occurring acids which are found in our environment. Okay, so you see vinegar, as already discussed, it contains acetic acid. All the citrus fruits like orange, lemon, they contain citric acid. Okay, tamarind contains tartaric acid. Milk contains lactic acid. Okay, tomato and spinach, they contain oxalic acid, and oxalic acid has one more application. It can be used to remove the ink stains on your shirt. Okay, so this also has to be kept in mind, right? Now there are some more, like we have ant sting, we have this plant. Okay, it's basically a plant. Okay, right, this plant is the nettle sting, and also the bee sting, right? If you see this bee, so bee sting, ant sting, right, nettle sting, they all inject acid. That acid is formic acid, or you can also call its IUPAC name is methanoic acid, and this is the formula of it, right? So they all inject this acid and it causes burning pain in the body. And obviously, since acid is creating problems, so you can take a base, you can take a baking soda, you can take any mild base. Okay, you can take calamine solution, okay, to get relief from this acid, right? Stomach, we have already discussed, it contains hydrochloric acid, right? Then apple, this carbonic acid, right? So some of all the carbonated drinks, they have carbonic acid. Apple has malic acid, tea has tannic acid, okay, coconut has lauric acid, and our urine, that also contains the uric acid, right? So basically acid can also be of two type. Okay, whenever you will visit the chemistry lab, so you will see few, things written on the acids, right? Conc, dil. So the meaning of this is the concentrated and dilute acids. Okay, so what's the difference? Like in the concentrated acid, the percentage of acid is relatively higher than the water. Okay, and on the flip side, you have dilute acid, the symbol is DIL dot. Okay, so they have relatively low percentage of acid and more of the water, right? So they have their own applications. To explain it further, I have uh, okay, so explain it further, to learn it better, you should know that concentrated acid, they will be more corrosive in nature than the dilute acids, right? So now the question arises, what should be done? Should we add acid to the water or water to the acid, right? It's a debatable question, but the correct answer for this is we should add acid to water and not water to acid, because addition of acid, water to acid, okay, is a highly exothermic process. Okay, it's a highly exothermic process, it will release a lot of heat that time. Okay, so that's why we have to be very, very careful with the concentrated acid. Okay, and please be in the supervision of your teacher when you're near acids. Okay, because their action, you can see the action is really very, very corrosive in nature, right? So it's better that we do experiments in the supervision of a teacher, right? Now how do we get to know, like we cannot taste, some acids are very corrosive. Just now you have seen this picture and the disadvantages of mishandling it. Okay, it can cause burns, it can be very corrosive. So that is one thing, we cannot taste acid every time, although we know that acid is sour in taste, base is bitter in taste, and we cannot taste everything. Okay, it may not be good for us every time. So what do we do now? Okay, so we have indicators for that. Okay, and it is not the first time you are hearing the word indicator. Okay, you already see indicators in your car. Okay, so if you are going to make a left turn or a right turn, you always get to know with the help of indicator. Similarly, you see in traffic light, you see three colors, okay? You see red color, you see orange color, and you see green color, right? So these colors indicate that whether you are supposed to stop or you can go, okay, depending upon the traffic. So these are the indicators only. They help us, they guide us, okay? Similarly, we also have indicators which help us in identifying acidic or basic nature of a substance without even tasting them. Okay, we are not required to taste. Okay, they will change the color, they'll change the smell, or there are various ways, but they will help you in detecting the presence of acid and base. Okay, right? So please remember, what are indicators? Indicators are nothing but a substance which will help us in identify acidic or basic nature of a substance. Okay, so if you see, basically indicators are divided into two categories: natural, which is found in nature, and synthetic. Basically synthetic, they are man made. Okay, these are man made indicators, right? So in natural indicators, we have litmus, turmeric, rose petals, petunia petals, purple, we have hydrangea. So there are so many natural indicators which are found. Okay, but apart from that, man has also prepared some synthetic indicators. We have methyl orange, methyl red, phenolphthalein. So we will be learning about few of them just now, right? So the first and the foremost one which everyone must know is the litmus. Okay, litmus paper, this is very important, right? So litmus is actually a purple colored indicator. The natural color of litmus paper or litmus solution is purple colored. Okay, it is extracted from a plant lichen. Okay, it belongs to the Thallophyta department, right? So this plant basically turns red when it comes in contact in the with the acidic solution, turns blue when it comes in contact with the basic solution, right? This is something you need to keep in your mind, right? Many questions are asked. Okay, like what will happen to the solution, okay, when you put red litmus, when you put acid, then it will turn red, base it will turn blue. Okay, now we have turmeric. It's a natural indicator, and again it's a very common ingredient used in cooking, right? So please remember, turmeric is a one-sided indicator. Okay, if you will put turmeric in a basic solution, okay, basic solution, like if you put it in, okay, like if you put it in soap, right, if you put it in soap, then it will turn red in color. Okay, it will turn red in color. However, in acid it will not change color. Okay, so definitely many times this happen that when your mom, when you have stains on your t-shirts or white shirts, and if your mom is washing it, right, the generally the food stain, which is basically yellow color, okay, basically it indicates indicator, turmeric natural indicator. So when mom applies soap, it becomes red. Now what is the reason for that? The reason is turmeric being a natural indicator, okay, and soap being basic in nature, so you get red color, right? So these are the real experimental results which you can see, which my students have performed these experiments, and you see what type of colors have come. Okay, so basically this solution is the soap solution, right? Now we have purple cabbage also, which give variety of color, right? You see the color is red in acid and green in base, right? Now we have phenolphthalein. Phenolphthalein is also a one-sided indicator. In acid you will not get any color, and in the basic solution you will get pink color. So please remember, P for pink and P for phenolphthalein. Okay, and remember the spelling of this also. Many times we write wrong spelling of this, which is not very good. So please be careful about this as well, right? And this is the color range. Okay, if it is very dark pink, but it's a strong base, right? Right, now methyl orange. So this is really a very good indicator, because you get different colors. Okay, like for you get red color for acid, orange color for neutral solution, and yellow color for a basic solution. Okay, so we have a trick for this, right? If you want to remember this, we have a very good trick which will help you in remembering. So you all must have heard of this movie Roy. Okay, and there are many students from Kolkata also, okay, like Ankita Roy, Shivani Roy, and Animesh Roy. So Roy is also a caste. Basically these people are found in Kolkata, so you just have to pay attention to ROY. Okay, so basically red in orange, sorry, red in acid, neutral in orange, and basic yellow color. And these are the real laboratory results which I am showing you. Okay, so definitely this solution is acidic in nature, this one is neutral, and this one is basic in nature, right? Now let's go to a different type of indicator. It's olfactory indicators. Basically, in your nose you have olfactory sensors, okay, which helps you in detecting the smell of anything, whether it is foul smelling or whether it is very fragrant in nature. How do you get to know? You get to know basically because of the olfactory sensors which are present in your nose. So similar to olfactory sensors, we have olfactory indicators also, which indicates the presence of acid or base, right? So we have three examples here. We have onion, we have cloves, and we have vanilla, right? So these are olfactory indicators. That means they change their smell to indicate the presence of acid or base. Now how does this happen? Basically, in the acidic, when you put olfactory indicators in the acidic solution, they give strong smell. Their smell, their audio, it becomes very pungent and very strong, okay. And in the basic solution, either they lose their smell or it becomes very low in nature, right? So, and this is the last kind of indicator, which is known as universal indicator. So as the name suggests, okay, it's universal, okay, means no matter what you're putting, okay, it will definitely give you some color with respect to its acidic strength or the basic strength. So you see the range of color. Basically, you all must have heard about Vidyar. So it is starting from violet color and ending at the red color, and in the neutral solution we have green, okay, like water. They are examples of neutral solutions. So you can also have a trick to remember this, okay. V I B, okay, basically VIBGY and O. So you can remember. You can also, this is a trick. Suppose if anyone says that this is uh, orange color given by universal indicator, so please guess the level of acidic strength and basic strength. So basically this trick will help you with your, right? So basically, what's the speciality of universal indicator? It's a mixture of several indicators, and it is going to give you different color for different level of acidic strength and the basic strength. So that's all about this. Now we will come to know about the next new topic, okay. So stay tuned and come back fast. Bye.